In this video, let's talk about the extreme value theorem. We did learn two types of extreme values of the function. We talk about the local extreme values and absolute extreme values. Yeah? And that's the definitions. What we will do today, we will focus on the absolute maxima and absolute minima. Using different words, too fast, we can say the highest point on the graph or the lowest point on the graph. What we learn that sometimes function actually doesn't have the highest or the lowest point. Yeah, depends on the domain, depends on the condition. May have the extreme value, the absolute extreme values, or may not have it. But talking about this existence theorem, which is one of the existence theorem that we have in mathematics, is the extreme value theorems. And this theorem will guarantee for the function under a certain condition that absolute maximum and absolute minimum exist. Yeah, the highest point and the lowest point, which is quite helpful solving some applications and applying this. Let's see the condition. Extreme value theorem. If f is a continuous function on the closed interval AB, then f attains an absolute minimum value f of c and absolute minimum value f of d at some numbers c and d in that interval. Right? That's what we can see. But the condition is function must be continuous function and must be defined on the closed interval. Yeah, that's really important to condition. We have to have a closed interval, and then always the highest point and the lowest point will occur, will happen. And I just draw 3 cases. Let's find out. Highest point, we can see absolute maximum, and actually this is absolute minimum. Okay, that's when it happens at the point CD between A and B. This one has absolutely highest point here and absolutely lowest absolute minimum here. Okay, we will look at this. And this one is, it happens actually 2 times, but this is still the same value, the same highest point. That's maximum, absolute, right? But it's the same value, because sometimes we will say, oh, it's twice. I mean, it's 2 now. No, it's just this. Let's say L. The L is the maximum value. It is happening at like 2 points, but it's just 1 absolute maximum. And this is the lowest point, absolute minimum. Okay, so we can see function is continuous, functions are defined on the closed interval, done. Now, how can we find out these points, this absolute maximum and this absolute minimum, if we satisfy the condition, continuity and closed interval? We may notice that some of them, like for instance, the second example is good. Some of them are happening at the local, at the critical points. Because we may notice we have function defined between A and B, and not always that highest and the lowest point will happen at the endpoints. And that's when we know A and B is given. A and B is given. That's the closed interval. That's the end of the domain for this function, and we can find out the values. Yeah, we can find the value. Like, let's say this value is 2, maybe this value is 1, and we can say, oh, 2 is greater than 1, 2 is maximum, 1 is minimum. No, because what we also have to do, we have to make sure that we identify the critical point and check what is happening at the critical point. What is the value? We don't have to really do the first derivative test, just the arithmetic, just substituting the value the critical point to the formula of the function and check the actual value, let's say 3. And now we can see, we will look at the value 1, 2, and 3, and 3 is actually the biggest number. 3 will be the absolute maximum and 1 will be the absolute minimum. And one of them, the maximum, is happening at the critical number, and the other extreme value minimum is happening at the endpoint. So that's 2 cases. Yeah? We may have absolute maximum and absolute minimum happening at both critical points. We can see the highest point, the lowest point. The same here, highest point and the lowest point. The endpoints are not even involved. I mean, they are still involved. We have to compute the values, but the extreme values happening at the critical points. Okay, that's what we will do. Let's try to find out the absolute maximum and absolute minimum. Before we do, let's look at the situation that actually function doesn't satisfy the condition of the theorem, and then it's not guaranteed. We will not use the extreme value theorem. The first example is showing us discontinuity. Function is defined between 0 and 2, the closed interval. It's supposed to be, it's 0, 2. However, we have some discontinuity, yeah, and this value is undefined, yeah, because that's the range, open interval. We do not have the highest point. We have the lowest point, absolute minimum, but not lowest point because of that discontinuity. Also, we may have continuous function, but defined on the open interval, the second case. And the same thing, that's not allowed. We don't know what is the lowest point, close to 1, but not, and highest point doesn't exist. Yeah? So always we have to make sure that we have closed interval and continuous function. Okay, now how can we find out? Yeah? As we notice, as we just mentioned, that absolute maximum minimum can happen at the critical numbers or at the endpoints. And that's what we have to do. We have to find out critical points. Okay? We have to figure out the critical numbers and then evaluate the values at the critical points and the endpoints, A, B, and find out whichever is the highest maximum, whichever is the lowest minimum. Let's do it. Okay, we have function x cubed minus 3x squared plus 1, polynomial, defined everywhere, no problem, nice and smooth and continuous function, which without the restriction, we will not have probably maximum or minimum, depends on the degree. But since we do have a restriction, we're only looking at the interval between -½ and 4. Okay. And then we have to find out what is the highest and the lowest point, absolutely lowest, absolutely highest point. And what we will do, I just type this, we will find out the value of the function at the endpoints, -½ and 4. And we also have to find out, I don't know, I just list 2, maybe we have 1, the value of the function at the critical points. That means, first of all, before doing this arithmetic, let's find out critical numbers. Critical numbers are the numbers where derivative is 0 or derivative is undefined. Derivative is defined everywhere for polynomials, then we have to just solve this equation. Okay, let's find out the derivative. 3x squared minus 6x, that's it, equals to 0. Let's factor out 3x. This product is 0 if 3x is 0 or x minus 2 is 0. Okay, we have 0 and we have 2. Excellent. 0 belongs to our interval. That's that because that's the domain for this question, this scenario, this condition. And 2 is also in that interval, because if this will end up, if we will end up having critical points not included in that interval, we're not looking at them, yeah, because that's our domain. Okay, that means 0 and 2. other critical points. Let's do the arithmetic and let's find out which number of value of x will give us the highest point on the graph. Okay, -1/2. We will just use this function and substitute, replace x with -1/2. -1/2 cube will be -1/8. -1/2 squared will be +1/4 times 3 and +1. Okay, we have -1/8, we have 6/8, and we have 8/8. Good. Common denominators. What we have, 14, 13/8. Okay, because we're looking for the highest and the lowest point. 4, let's substitute 4. 4 cubed is 64. 4 squared is 16 times 3, 48 plus 1. 64 minus 48, 16 plus 1, 17. Okay. And 0, 0 is a nice, it's just 0. 2 cubed is 8, 4 times 3, 12 plus 1, -4, -3. Let's make it a little bit nicer. We know how to add fractions. 13/8. It is 13/8. Yes, because it was 14. Okay. And now we're just looking. This looks like the highest point. This will be absolute max. And this one looks like a lowest number, absolute minimum. Okay. And we don't know exactly how function looks like, but we know that at 2, the value is -3 and 0 is 0, 0, but we don't, that's not the, and at 4, which actually is the end point, value is 17. This is y, this is x, 17. We also know -1/2, which is -1/2. It's like less than 2, 13/8 here. And I don't know exactly how this function looks like, but I'm assuming that it's something like this. Yeah? That's the max, of course, absolute, and that's the minimum, absolute. Yeah? The lowest and the highest one, because that's what we're looking, highest and the lowest. 17 and -3. The endpoints, the endpoint 4 gave us maximum, but not the endpoint -1. Okay, let's just do another one. We have, my graph is, what's the value for -1/2? Okay, maybe I'm just looking at the graph and -1/2 suppose, or maybe something. Oh, okay. Let me, this is supposed to be like, a little bit here, +2. Okay, makes sense. That's the value. I hope we did the arithmetic. Definitely we find out -3 and 70. Okay. Now let's look at the next one. The same thing. Let's just repeat. That's when you will have enough practice. And I have one more. I have this exercise and one more, and we will be done with this existence theorem. Find the absolute maximum and minimum value of the function 3x cubed minus 12x squared plus 1 on the interval between -1 and 1. The same thing. Since we are asked to find the absolute maximum, we see function is continuous, defined on the closed interval. Yes, the values definitely exist. Okay, we will try to find the value at the endpoints for 1 and for -1. Yeah, and we need a critical point. I don't know, maybe we have 2, maybe we have 1, we will see. Critical points are the points where derivative is 0, since derivative is defined everywhere for polynomials. Okay, what we have? We have 9x squared minus 24x equals to 0. Right, let me just put f prime of x equals to 0. Okay, we can factor out 3x. It will be 3x minus 8. Am I right? 9, 25, yes. And then this product, this factored form is 0 if one of the factored is 0. X is 0, or x is 8 over 3. 8 over 3 is 2 and 2/3. And we may notice 0 belongs to the interval from -1 to 1. But this one actually really nice because we don't, I mean, we can still evaluate, doesn't depend to the domain. Domain is from -1. This is our domain. Yeah, that's, we will not use it. Please, yeah, please pay attention to the domain. Domain is that closed interval. Yeah, doesn't depend. That's away, far away. And yeah, it's a critical point, but we cut the domain. We make the restriction. Okay, that means only 0. We will not use the other one. I can even erase this. 0 is nice calculation. Okay, let's substitute -1. -3, -12 plus 1. What we have? -14. 1. 3 minus 12 plus 1. What we have? -8. If I am right, 4, yes, -8, okay, and 0 will give us 0, 0, 1, 1. Okay, looks like this one is absolute max, and this one is absolute minimum. And we don't have to draw it, we don't have to, but we can try y and x, and -1, 0, and 1. For -1, oh wow, -14. Yes, this is the lowest point. For 1, we have -8, but for 0, we have 1. And this is maximum. This point is minimum. I can draw a function. Since it's continuous function, I don't know exactly how the function looks like, but I'm just guessing that will be there. Okay, highest point at critical point, lowest point at the end point, -1. Okay, and one more, but this one on this slide, please make sure that you know to eliminate. And yeah, let's do the same thing. Looks like we have options, looks like an exam type question. Let's do it. The same thing, we have polynomial, absolute maximum minimum. Polynomial is continuous function defined on the closed interval. So first of all, let's maybe start with the derivative. Derivative is 3x squared plus 8x minus 3. Am I right? 3x squared plus 8x minus 3. Okay, I just don't like factoring out this, but we will try, we will try. Okay, and now we have to solve this equation. Yeah? Derivative must be 0 if this quadratic form is 0. Okay, and I don't know, but let's try to factor out because we have to find out zeros. If we cannot factor out, we can always use quadratic formula. I should not panic. Okay, factors of 3 of the constant number is 3 and 1. And 3 times 3 is 9, minus 1, it is 8. So we can put plus and minus. Actually, yes. I was a little bit afraid because I saw the leading coefficient 3. Is that right? And -3, +9 minus 1 will give us +8. Great, excellent. Okay, we have nice. This factor must be 0 or this one must be 0. x is equal to 1/3 and x is equal to -3. Now we're testing against the domain. Our domain, our closed interval is between all of the values between -2 and 1. -2 and 1. This one doesn't belong to the domain. Domain is an interval from -2 to 1. We're not using -3. Okay, but 1/3 is in that interval. Yes, 1/3 is, okay, we will substitute, we're using 1/3. Okay, we have to find the value at the endpoints, -2 and 1, and the value, corresponding value for at the critical point, not using -3, not in the domain. Okay, let's substitute. We're using the original function, x cubed, -2, maybe I can write this down, -2 cubed plus 4 -2 squared minus 3 times -2. 8, or maybe I can write here 8 plus 16 plus 6, correct? Oh, I erase why I did it. -3, -2. Okay, 22, oh, 30. Oh, am I? Oh, no. This is negative number taken to the power of negative, odd number, it will be negative. And that's when we have 22, actually 14. And you probably notice I just figure out because none of the option is 30, then possibly my answer was not really, it's not correct. 14 is the option. And that's how we can correct ourselves. We have to pay attention. Okay, substituting 1 will be nice and easy. 1 cubed plus 4 times 1 minus 3 times 1. That's nice and easy. 2. And 2, I can see one of the option 2. And 1/3, 1/3, 1/8, or not 1/8. 3 to the power of 3 is actually 27. And then plus 4 times 1/9 minus 3 times 1/3 is 1. And what we have, 1/27 plus, if this is 27 times 3, 12, and 27/27. What we have? We have 13 minus 27, -14/27. Okay, since this is negative, looks like it's small m, absolute minimum, that's the symbol, that's the notation, and this one is the highest value, looks like absolute maximum. That's it. Absolute max. Okay, and I hope we have this option 14, and this one is the option A. Yeah, but please be really careful with the arithmetic. I did miss that negative, but I corrected myself quite quickly. Always be aware what we're doing, and take the advantage this way that I took, the advantage of the options. Or never guess the value because it could be misleading. Okay, thank you. You may go through these problems, do your assignments, and you will be good with this theorem. Thank you.